Hi, algebra students. So these are the notes that we took in class and about properties, using properties to solve multi-step equations. And so if you have this copy of the already printed notes that we did in class today, then that would be a good idea to fill that in. If you don't have a copy of this, then it might be a good idea to just fill it in and just kind of draw in the chart. And so this is just a review of some of the properties that you have learned over the years. Most of this should be review. Some of it will be new. We start with the multiplicative property of 0, and the multiplicative property of 0 just means that any number times 0 is 0, right? If we take anything, x, 3, 7, 9, negative 22, and we multiply it by 0, then we still get 0. So that's the multiplicative property of 0. Notice that there is no additive property of 0. We're going to get down here at the bottom to what it means to add something to 0. The other property here that we need to know is called the zero product property. Now these two things are different. This means that you can multiply anything by 0 and you get the answer 0. The zero product property says that if two numbers are multiplied and it equals 0, then one of them had to have been 0. So again, it's slightly different. Multiplicative property is 0, and then the zero product property. We're going to use this property a little bit later in the year, but the zero product property says that if I multiply two things together and the answer was 0, one of those things, either A or B, or maybe both, had to have been 0. Another property that is going to be useful to us is what I call the most obvious property of all, which is why it's called the reflexive property. Think about a reflex, how it's just like so straightforward. If something is a reflex, you just automatically do it. The reflexive property says that for all real numbers, x is always equal to x. Like if you have something and it's equal to itself, that's always true. Something is always equal to itself. And we'll see how that sort of plays out in our solving of equations here in just a minute. So reflexive property is just like obvious, duh, something is equal to itself. The symmetric property says that you can actually switch sides. So we do this a lot of times with equations, especially if we don't like that something's on the right side and something's on the left. Symmetric property means that, just like a butterfly, it means that one side is the same as the other side and they're interchangeable. So for all real numbers, if x equals y, then it's also true that y equals x. It just means that you can switch not just the order of the numbers like we would in the commutative property, but the physical sides. The left side can be interchanged with the right side and nothing changes. So that's called the symmetric property. The transitive property is of equality is for all real numbers. If x equals y, so if something x, some number x is equal to a second number y, and that same second number is equal to z, then it must be true that the first x and the third z are equal to one another. So again, if x equals y and y equals z, then it must be true that x equals z, that the first thing equals the second thing. And we'll see some more examples of that here in just a minute. But it's almost like you can forget what's in the middle. If something is equal to something and then that same something is equal to something else, then those two outside things had to have been equal as well. The distributive property is something that you have been using now for quite a while. It just means that multiplication of a sum can be written as the sum of each term multiplied. It means that if you have something being multiplied on the outside of parentheses, you can distribute that multiplication to everything on the inside. So that's something that we have done. These next four, it might even be a good idea to sort of highlight these. These are going to be used a lot. So this addition property of equality, I'm just going to sort of darken this in. All these four right here are going to be super important. Addition property of equality, subtraction property of equality, multiplication property of equality, and the division property of equality. These are all the properties that, again, you've used this before, but it tells us that if we add the same number on each side of the equal sign, that it keeps it balanced, that we can do that in order to solve an equation. So the addition property means that if you had a question like a one-step equation, just like x minus 7 equals 13, that you could add 7 to both sides and of course cancel that out, and that you can do that. You're allowed to add what you add to one side, you can add to the other. We call that the addition property of equality. It keeps the sides equal, and we get our answer that way. Same thing for subtraction. When we subtract the same number on each side of the equal sign, again, if it were an addition equation and we were subtracting 9 on each side, that we can do that. If you subtract something from one side and you subtract that same thing from the other side, it keeps the sides equal. That's called the subtraction property of equality. Same thing is true about multiplication and division, right? If you multiply the same number on each side, usually we do this when it's a division problem in the first place. So the original problem was x over 4 equals 9. If you multiply both sides by 4, it keeps both sides equal. That's the multiplication property of equality, and we get our answer that way. And again, same thing for division. You are allowed, it is true that if you divide one side by 7 and divide the other side by 7, that you keep the sides equal in order to get your answer. So those properties of equality, all of those, notice, are of equality. It's just that step that you do to each side of the equal sign to keep it equal. Another property that we need to know the name of is the substitution property. We've been actually practicing with this in class. It's that if A equals B and 4A equals 12, then you can literally pick up and you can substitute, right? If you know that A is equal to something and you've got an equation with A in it, you can substitute in for that A. So we're saying if A equals B and 4A equals 12, then that must mean also that 4B. You just you literally plug in what you're given. A lot of times this is a number, right? So if we said A equals 3 and we've got 4A equals 12, then we know that 4 times 3 is equal to 12. We can just substitute it in. We can plug it in for any missing value. And then of course we have all of the properties that are old to us, but are nonetheless very important. Let me move this down a little bit. We have the associative property. Remember, that means we can change groups. What that means and what that looks like is that if you had something like 2 plus 3 plus 4 in parentheses, that you can associate those differently. So we could actually, not changing any order, it's still going to be 2 plus 3 plus 4, but you could actually group together the 3 and the 4 in parentheses and it would not matter. Commutative property means that things can change order. So 2 times 3 is obviously the same as 3 times 2. The order changes. The identity property are those things that stay the same. So anything times 1 remains the same, and also anything plus 0 remains the same. If you do 5 times 1, it's still 5. If you do 5 plus 0, it's still 5. Whatever you do to the number, anytime you multiply it by 1 or add 0, it stays the same. That's the identity property. And then the inverse is doing the opposite. So when we think inverse, we think opposite. So reciprocal, it would be like 5 times 1/5. Those are reciprocals of each other. And also when you're adding, it's a negative number. So 5 plus -5. Those are the inverse properties. So that's a super quick review of all of the properties that you're going to need to know. And we're going to use this as sort of a reference sheet, because what you're going to do in your practice is you're going to actually solve an equation and you're going to justify how you solved it. So if we look at this first example on the inside, it says to solve an equation, our goal is to get the variable by itself. And so as we do these steps, we're going to name the property that we use. So if we look at the original problem, and I've already worked these out, but if we look at the original problem here, it's x minus 7 over 3 equals negative 12. Well, that's given. So your first step is always going to be, okay, I was given a problem. And then after that, well, what do I do to solve this? Well, the first step I would solve is to multiply each side by 3. What property tells me I can do that? The next property, I'm multiplying by 3 on each side. So if we look back at our list of properties here, the fact that I can multiply something on each side, that's the multiplication property of equality. Now, I shorthanded it here, the multiplication property of equality, the MPO. But that's the second step. That's the second thing after we're given the problem. That's what we're using to solve. So we write down that property. We just need to be able to name the properties as we go. Now, once we multiply each side by 3, it cancels over here, and over here we get negative 36. Now we have x minus 7 is equal to negative 36. And of course, how am I going to get x by itself? I have to add 7 to both sides to cancel it out over here and then to get an answer over here. Well, the fact that I am adding 7 on each side means that I am actually using the addition property of equality. So again, I told you to highlight these. These 4 are going to be ones that you use a lot as far as you're doing these problems. And because we're adding the same thing to each side, that's the APO, or the addition property of equality. And so that's it. We get our answer, and once we get to our answer, we're done. But that's just a very short example of being given a problem and then using properties in order to justify, well, why can't I do this step? Why can I do this step? Now, the next one is a little more complicated. It's a little longer, and we're actually going to use the property of combining like terms, which is not actually a property that we had listed on the front, but it's a property nonetheless because we know how to do it. And so here we notice we're given the problem. You write that down, always given first. And then the first thing we actually do is use the distributive property. And so that's the first thing we're gonna write down. And again, once you do the step, you're gonna write down the property of why you were able to do that step. So we distribute the -8. We get our next answer down here on the next line. And then we say, okay, well, what would we do next in order to solve this? Well, we know that the next step is to combine like terms. And so we combine like terms. Now combining like terms is not actually a property, again, that we listed over here, but it is a property that we use. And so we're just gonna write combine like terms. That's its own property. Once we get our like terms combined, we're ready to add on each side. So the APO, the addition property of equality, is the next property. And then we've got the division property of equality once we divide in order to get our final answer. And so the division property of equality would be next. All right, now the last one here, before we get down here to the very bottom, the last one here, again, we would work out each step. Notice that the first thing you would actually do here, there's no distributing, so we're ready to combine like terms. The only thing you can actually work out after you're given is to do this, 7 times 0. And we said on the front that that's the 0 property of equality. Anything times 0 is 0. So we go ahead and write that down. 7 times 0 is 0, but then it goes away. Well, how do we know that we don't have to write, like how do we know that we could just ignore that? Well, the next property we would use after we bring everything down is that we would actually have to still combine -23 plus 0. That's an identity property because that means we're keeping it the same. That's why when you get 0, you know, like, hey, I really could have not written it there. And that's what we're doing down here on this next line. That's the identity property. Now we're ready to solve it to bring the variables to one side. We're doing the addition property of equality because we're adding the same thing on both sides, even though it's a 2m. Addition property of equality. We get our next line, 5 equals 7m minus 23. We're ready to add 23 to both sides and get rid of that. That's another addition property of equality. So we're gonna do the addition property of equality there. And then we're ready to divide. So you divide by 7. I had to bring my work over here. Divide each side by 7. That's the division property of equality. And then the last thing is that if you end up with your variable over here, we could actually switch that around. So it's kind of weird to say 4 is equal to m, but if you switch it around, then it's the symmetric property. We know, again, that if we have a left and a right side, that we could actually turn those around and not be such a big deal. And so the symmetric property is actually, oops, I knocked something off my desk. Symmetric property is actually right here, right? It's this property that tells us we could switch things around. So that's an example of what we're doing as far as solving equations and then listing our justification for why it's possible. All right, this last one down here, and I'm gonna fill this in as we go here. The last one down here is a problem where we're actually gonna use this transitive property. And so if we read it, it says, if 7 plus x is equal to 15y, and if 15y equals 30, then solve for x. And so we've got two parts here, but notice what's true about the things in the middle. We've got a 15y. That should ring true if you look back here at what we said about the transitive property. If you have the middle thing that's the same, if x equals y and then y equals z, then you can actually set the outside things equal to one another. So what we're gonna do on this example is that actually if 7x equals 15y, and if 15y equals 30, then what must be true? It must be true that 7x, x plus 7, excuse me, is equal to 30. It's almost like, again, that middle stuff just goes away because they're equal to each other. They're the same. So we can set the outside things equal. And so that, of course, we were given. And then we use the transitive property. Transitive property, you can just write transitive. And then the last step is going to be to subtract 7 on each side. And we get x is equal to 23. That last step there, what tells us that we can subtract on both sides? It's the subtraction property of equality. And then we get our final answer. And so that is how you use properties in order to justify your solving.